All right, let's jump right in. Today, we're talking about a new kind of AI. This isn't just an AI that answers your questions. Oh no, this is an AI that's actively getting its hands dirty in scientific discovery. And honestly, the results are already a huge game changer.
But before we get into the nitty-gritty, I want to ask you something. What do you think is the single biggest bottleneck in modern research? What's the one thing holding science back the most? I bet the answer is not what you think it is.
Believe it or not, for a huge number of scientists today, the answer is writing custom software. You see, to run experiments, to analyze mountains of data, or to build complex models, they need specialized code. And building that code is this slow, painstaking process that can take months, sometimes even years. Okay, so let's really dive into this problem. A massive chunk of modern science, we're talking everything from modeling diseases to predicting climate change, it all relies on something called empirical software. Now, that's just a fancy way of saying you're writing software to be the absolute best at a task you can actually measure, or score. So think about it like this. Predicting deforestation from a satellite image, or finding a weird pattern in a single cell. Those are what we call scoreable tasks. The better your code, the higher your score. Simple as that.
So here's the kicker. This whole process is incredibly hard. Scientists are brilliant, right? But they're also human. They have to rely on their gut, their intuition, and they just can't possibly test every single idea that pops into their head. The time it takes to write and test the code is so immense that countless promising ideas just get left on the cutting room floor.
But what if you could automate that entire process? I mean, what if an AI could not only write the code, but also tirelessly search for the best possible code? Well, that is exactly what this new system is built to do. So how does it work? Well, it's got this really clever two-part strategy. You can think of it like a brain with two halves. One half is the large language model. That's the creative brainstormer, just spitting out tons of code solutions and wild ideas. The other half is a tree search algorithm, which is like the super organized, methodical project manager that tests all those ideas and decides which ones are actually worth pursuing. And this right here is the engine that drives the whole thing. It's this relentless feedback loop. The LLM suggests some code, that code gets run and scored. And then the tree search looks at that score and tells the LLM, okay, that was pretty good, now try something like this. And it just repeats that over and over and over, constantly improving itself automatically.
So, the million-dollar question, does it actually work? Well, the researchers threw it at some of the toughest problems they could find, across totally different fields of science. And the results? They're frankly stunning.
Let's start with genomics. This is a field that is absolutely drowning in incredibly complex data. Just trying to analyze individual cells from thousands of different experiments is a monumental challenge.
So they gave the AI this task, and it didn't just find one better solution. Get this, it discovered 40, that's 40, completely new methods that beat every single human-developed tool on a major public benchmark. It wasn't just improving code, it was basically inventing new science from scratch.
This is a perfect example of its power in public health. So for this chart, a lower score is better, right? The AI was asked to forecast COVID-19 hospitalizations, and as you can see, its models were way more accurate than the official model used by the CDC, which, by the way, combines forecasts from dozens of different expert teams. The AI beat them all.
And the wins just kept on coming. Take geospatial analysis, basically teaching a computer to understand satellite photos. It's incredibly complex. Look at this table. The AI solutions didn't just inch past the competition, they blew past highly specialized methods that were literally just published in top academic journals. That's not just an improvement, that's a massive leap forward.
And if that wasn't mind-blowing enough, they pointed it at the insane complexity of an entire living brain. It created models that could predict the activity of over 70,000 neurons in a zebrafish brain more accurately than any other method out there. We're talking better than specialized models that took way more time and computing power to even train.
So what is going on here? What's the secret sauce? How is this system getting these, well, superhuman results? It's not just because it's fast. It's because it thinks about finding a solution in a totally different way.
One of its key tricks is this ability to creatively smash existing ideas together. So in that genomics challenge, its best solution came from this brilliant hybrid idea. It looked at two separate methods and basically realized, hey, this one is good for big picture errors and this other one is good for the tiny local errors. So it just fused their core concepts into something brand new that was way more powerful than either one was on its own.
And this comparison really gets to the heart of it. A human scientist, no matter how brilliant they are, is limited by time, by energy, by their own biases. They physically cannot explore every single possible path an idea could take. But this AI, it can. It will exhaustively, tirelessly search a massive universe of possibilities, finding those incredible needle-in-the-haystack solutions that a person might never, ever have the time to even think about.
So what does all this mean for the future of science? I mean, the implications here they're profound.
The biggest takeaway is a potential revolution in the actual speed of science itself. Think about it. If you automate the most time-consuming part of research, you could compress the timeline for exploring a totally new idea from, say, a couple of years down to just a few days.
And hey, don't just take my word for it. That's coming directly from the researchers who built this thing. They believe that any field where you can define and score success with a computer is about to hit the accelerator, hard, thanks to tools just like this one.
Which leaves us with a truly fascinating question to chew on. We've just seen an AI that can act as a brilliant tool builder, a true co-scientist that can outperform human experts at their own game. So the next logical step is for it to make a fundamental discovery all on its own. The question is no longer if that will happen, but when.